example, right? So how do I do script? I right click first of all manually. You always need to do it manually first. Right? For example, I have this device. Right. So now our interest is to cut the Venn diagram. Right? I can zoom in. And then I say I cut the y-axis, right, vertically, like what you have been doing. And then I get this one, right? And then I can say I want to plot the Venn diagram. I just click this one. There are many ways you can plot the Venn diagram, like this. Right? So this is the Venn diagram. I zoom in again. Now, sometimes you want to create your own screen. Like for here, if I just click on any other things, for example, I say I only want to click on the conduction band, then what do I want to say? I just want to say it's very slow. For example, I just click on conduction band, right? Then everything is gone. I can say I click on band gap narrowing, then it only has band gap narrowing, right? So I can also say duplicate plot. I duplicate it. Then in this case, I can select what I want to plot. For example, I plot X to X-axis, right? And then I say plot also the, for example, wavelength span to Y-axis, right? Then I can have both of them at the same time. I don't know if you're aware of this, right? And then I zoom in. Of course, you can have many figures at the same time, right? And then now you see each of these action has a corresponding command. Okay.
Yes.
Actually, later I am planning to ask you to probe. For example, I want to probe the electron Fermi level, E quasi Fermi potential. For example, I put into the left. And turn out this, so this is the Fermi potential. We need to be careful if this is the real Fermi potential or actually this is the Fermi level. It may flip by negative value, right? So I decided not to do this. I let it plot it for me. I just click on the Venn diagram, right? But you need to just check to make sure. Then I zoom in again to this region. I think I plot the wrong one. I plot the quasi-Fermi potential, right? Or right, or no. Yeah, anyway, this is the potential, right? And I go to the curve. I see this conduction band. I see this Fermi level.
Yes.
Right? So later I may say, hey, can you extract the difference between the conduction band and the Fermi level? Right? Manually, you will just move your cursor to here and then try to look at the bottom. Right? Somehow this is gone. Very slow. Usually, the bottom will show something. But my display has some problems, so you don't really see it. Right? But anyway, that is not good. So what I can do is I click on this probe command. But in order to probe, let me just remove the wavelength span because I know I don't want the, okay, now I can see it, right? If I move, let me remove wavelength span first. I press delete key, remove the whole potential. I press the delete key, right? You see now if I try to navigate here, right? At the bottom, you see XY axis, right? So in principle, you can zoom in. I don't know why it is so slow. You zoom in and then move it, right? And then I move my cursor here. It's so bad. Right, then maybe I am able to find out what is the value. Then I do the subtraction. But I will say, but you don't want to repeating this forever, right? So what you want to do is to use this probe command. Click on this one. You see one probe. Then I come here, right? And then I click on this. This tell me what is the value here on the bottom of the conduction band and this one, right? But this basically not saving me any time. But the good thing is this. Now I can save the script. right? I call it test. Let me just call it test. I save it as TCL. And then I can come here. I just insert so slow. A new, I need to add a new SVisual. Right? Somehow the system is very slow now, or my internet is very slow. What's going on? Right? So, and then I add the SVisual. It's just so slow. My system should be okay. Let me pause the recording for a while. See what I can do. That it will do it automatically for me. And I need to import that file, right? So import the file, I just say import. And then I remember the name is called test.tcl. I say open, and then just OK. Okay. Then if I try to right click this SVisual, look at the
Professor, I can't see the screen. It's just frozen on my end.
Oh, okay. Sorry.
Okay, now I can see.
Now you can see it, right?
Yeah.
But then my recording. Hold on, just hold on. I want to make sure I'm recording.
Okay, no problem.
Do screen sharing. Oh, so maybe actually I have been.
It says recording in the right-hand corner from
Okay.
my side.
So let me delete it. I try one more time so you can see it. So here you see I try to add a new SVisual, right? Here. And then and then I go to input file. I say import. I remember what I just saved, right? Test.tk, right? And then I say okay. Right? I save the project. And then right click, I can look at the command. Right? So these are all what I have done. I load this file, remember? And then zoom in, I did many different things. Okay. If I don't do anything to this, right? I just run this one.
Oh, the plot would show up then?
Exactly. It will just repeat what I have done.
Okay, that's very convenient then.
Yeah, then you can keep repeating for everything, right? But it's not that simple. You need to do a few more things, but you see that it just repeat what I have done. I cut it, zoom in, cut it, right? I'm not touching my computer now. It just repeat what I've done. Right? And then it has all these things. I create a new plot. I show you, I can zoom in, zoom out, and then probe it, right? But the good thing about this is this. Now with this one, I can make it like this. First, I remove this absolute path. It doesn't matter. But then I want to remove N6. Not remove. I replace N6. N6 to N previous. Okay? Because this node if I type F9, it's 36. The one before it is N6. It always open those N6, but now I want you to do N previous. So that even when it comes to other node, it's going to open the structure of N8 if it is at 8N38. You see what I mean?
Yeah.
Okay, good, right? So I'm going to replace it, right? So I say N6 replaced as N at previous, I replace all. Then automatically it replaces all of it.
Okay. That's
Now,
very cool.
I save it, and another great thing is, remember, I try to probe it. And remember, you say you want to cut it at a certain location. You search for the cut, right? Where did we do the cut? We say create cut here, right? And then we actually cut here, cut 9. Now you say I want to be absolute. I just put 0. Any location you want. Okay? Make sense?
Yeah.
Okay, good. I also try to probe it, right? Now, this one I need to can probe it exactly at the interface. Right? I don't know where's the interface, but let me say just for, I can look at my real structure. Right? This is the real structure. And then I try to look at the interface. Oh, looks like it is at 0. Right? The interface is 0. So I want to probe at 0. This one is going to give me some number. I use take-call command, set, and this is a command. I set a variable. Let me call it energy value, right? It doesn't matter any energy. It actually returns 2 variables. So how do I extract them? I just use the take-call command. I can say, and then I want to output to the SWB. This one, you use take-call command to put EOE. And then, for example, you say EC. Right? This one I explain to you later. And then we put what? We can put L index and other energies. I type it first, and then later you know, and then explain to you. And this is, let's say, Fn. So this is what it does. When it probes something, it returns 2 value into an array. Now I call it energies. Okay, this is a variable. To use this variable is an array is something called L index. It means I take the first one that is this value and print, okay? And then print it. This is take the second one. So the index is 1. So in SWB, the special thing is if you try to print it using the put statement with this command DOE colon and something and then a number, it knows that it's going to create a variable called EC and then put the number in the SWB there. Let me show you what it does. Right, so now I'm going to close this one. Because I'm running this in the so-called interactive mode, so it will pop up. I'm going to do batch mode. Right, I right-click SVisual and then choose property, batch mode. Now I'm going to click this one, and then I let it run. Nothing will pop up, but it will do the extraction for me. You see it here?
Okay. Yes.
Okay, but obviously I did something wrong in my code. It gives 2 number. Okay, why it has told it's not that I did something wrong. It's because maybe I probing right at the interface. So it has an oxide number and also a semiconductor number. So I better maybe just shift a little bit. Let's say 1E minus 6, very close to it. Right, and then I run it again. Now then you see this number, right?
Yeah.
And I can do more. For example, later I ask you to give the difference. Then you can say put, right? EOE, difference, delta. But now I actually need to create a variable first. So I did not do a good job. Maybe I should, for example, here, right? I should just do here. I say set EC as this one. Then this is a variable. So when I call it, I just call $EC. Make sense?
Mm.
Let me just quickly finish this, right? And then here I use 1. I say EF, right? So here I becomes $EF. And now the delta will be another command called expression $EC minus $EF. Right? If I have this one, then I let it run. Of course, you can do it manually, but let it do it automatically for you. Right? Then I have the delta also over here. Then how is it going to be useful? Then you will go to experiment, export, test file. It's going to export this table to a test file, transport.csv. Right? If I click on here, go to the directory that I'm working on, you will see there's something called transport models.csv. It gives you the CSV file with all the split and also all this extracted data. Then you can output to Excel to plot them.
Okay.
Okay. Yeah. So this is a little bit early to tell you this, but I hope that you start doing this because that will take a lot of time.
Yeah, I'll practice that actually. It seems very useful.
Okay, great. I will